Today we continue with gas laws. We continue with gas laws, and today we are going to talk about Charles law. Charles law. Charles law states that the volume of a fixed mass of a gas is directly proportional to its absolute temperature at constant pressure. Mark the word absolute temperature. So when we talk about absolute temperature, we are talking about temperature in Kelvin. So there is need for conversion from degree centigrade to Kelvin. So let's look at the mathematical expression of Charles law. Volume is directly proportional to temperature. We introduce our constants. We have V equal to KT. So that means V over T equals to K. So we have V1 over T1 equals to V2 over T2. This is the mathematical expression of Charles law. Now, according to kinetic theory, which says that matter is made up of particles which are in continuous motion, and that the particles of matter possess kinetic theory. Charles law is one of the gas laws fully and well explained by kinetic theory. Here, it states that when you increase the temperature of a gas, the kinetic energy of the gas molecules also increases. And when that happens, the gas molecules will begin to spread out, move to occupy a larger space, or what we call volume. And when you decrease the temperature, the particles will move, the kinetic energy of the particles will decrease. And as well, the volume will also decrease. So we have this law telling us that as the volume is increasing, the temperature is increasing, the volume increases as well. And as the temperature decreases, the volume decreases. So we have a graph representing the Charles law. Let's look at the graph representing the Charles law. If you are making this graph, if you are drawing this graph, it's better you start with a T that is upside down. We know that you write T like this, but if you want to draw Charles law, you will draw a big T, but that T will be upside down. So let's have the T upside down. That's my T in an upside down position. And then from any point on the x-axis, you begin to move up. From the x-axis with a dotted line, move up and let it meet the y-axis. And then from the y-axis, you continue with a straight line. That's Charles law. And then you begin to label. This is point of origin. This is minus 273. And that tells you that this area, this x-axis is occupied by temperature. So we have our temperature measured in degrees centigrade. And then we have our volume here, measured in cubic meters. So this is what we call Charles law. A T in an upside manner. Then you move the graph. With a dotted line, you connect the x-axis to the y-axis and then move with a straight line without the dotted line. So minus 273 in degrees centigrade is equivalent to 0 Kelvin. The absolute temperature is 0 Kelvin. At this particular temperature, the volume of every gas is 0 meter cube or 0 centimeter cube, whichever way you want to measure it, using either cubic centimeter or cubic meters. Every gas at minus 273 degrees centigrade or 0 Kelvin has no volume. The mathematical aspect of it. So we are going to have some problems. A problem here on Charles' law. Says a fixed mass of gas occupies 100 cm cube at 50 degrees centigrade. Determine its temperature. Determine the temperature at which its volume is 250 cm cube, assuming the pressure remains constant. So we have V1, the initial volume, to be 100 cm cube. We have the T1 to be 50 degrees centigrade. We convert to absolute temperature. We add 273 and we say in Kelvin. And that will give us 323 Kelvin. Then we have V2, the second volume, which is 250 cm cube. And we are asked to look for T2. That is the new temperature at which the volume is 250 cm cube. So T2 is what we don't know. We go with the formula. V1 over T1 equals to V2 over T2, making T2 the subject of the formula. We have T2 equal to V2 T1 divided by V1. And then we substitute. What is our V2? 250. What is our T1? 323. And what is our V1? 100. And that will give us, 807.5 Kelvin. If we convert this to degrees centigrade, we subtract 273 from it, and that will give us 521.7 degrees centigrade. Now let's look at 534.5 degrees centigrade. 534.5 degrees centigrade. Let's have the second problem. A gas occupies 500 cm cube at 27 degrees centigrade. Calculate its volume at 40 degrees centigrade at constant constant pressure. So let's look at our V1 here is 500 cm cube. Our T1 is 273 degrees centigrade, but we have to convert to Kelvin. So we add 273 all in Kelvin, and that will give us 300 Kelvin. So we have V2, we don't know. We're asked to get the V2, and our T2 is 40 plus 273. and that will all in Kelvin, and that gives us 313 Kelvin. So we apply the formula V1 over T1 equal to V2 over T2. Here we make V2 the subject of the formula. V2 is equivalent to V1 T2 over T1. So our V2 is equivalent to, what is our V1? The initial volume is 500. Our T2, the second temperature, is 313. And then our T1, 300. And that will give us 521.7 cm cube.